Kata is something you practice, not something you watch. Read the lesson, write the code yourself, then review what you wrote. This video is the reference you come back to afterwards. A model can produce this code in seconds, and the reason to write it by hand is to keep the judgment that tells you whether the code is any good. useReducer is usually introduced as the hook for complex state, which is true and not very useful because nobody knows where complex begins. Here is a sharper version. Reach for it when the interesting thing about your state is not the values but the transitions. When what matters is that submitting moves you from editing to sending, and that failing moves you from sending back to editing with an error attached. useState scatters those transitions across every handler that performs one. A reducer puts all of them in a single function you can read top to bottom. 2 arguments in, 2 values out. You pass a reducer function and an initial state, and you get back the current state and a dispatch function. The reducer takes the current state and an action and returns the next state. That is the whole contract, and the important word in it is returns. A reducer does not modify anything and it does not perform any work. Given the same state and the same action, it produces the same result every time, which means you can call it in a test with no React anywhere in sight. Dispatch is the other half. You do not tell React what the new state is, you tell it what happened and the reducer decides what that means. A counter is too small to need a reducer, and that is exactly why it is a good first example. Nothing is hidden. 3 actions, increment, decrement, and reset, and a switch statement that handles each one. Compare that with the useState version. The rule for incrementing lives in the reducer here next to the rules for the other 2 instead of inside the button that happens to do it. That relocation is the whole trade, and at this size it costs more than it earns. Look at the shape, not the value. A form is where it starts to pay. Several fields, a submitting flag, an error, and rules connecting them. Submitting clears the error. A successful submit resets the fields. A failure keeps them. With separate pieces of state, those rules end up spread over 3 or 4 handlers, and any handler that forgets one leaves the form in a state that should not exist, like submitting and showing a stale error at once. The reducer version makes each transition a single case, and the states that should not exist become states you simply never return. The to-do list shows the other reason to reach for this, arrays. Add, remove, and toggle are 3 operations on a collection, and each of them is a small piece of immutable update code, spreading and filtering and mapping. Inside a reducer, those sit together and read like a list of the things this data supports. Notice that every case returns a new array rather than pushing into the existing one. That is not ceremony. React compares the value it was given against the previous one to decide whether to re-render, so mutating the array in place produces the same reference and the screen does not update. The comparison on screen is fair, and I would reduce it to 2 questions. Do updates to this state depend on other parts of the same state? And are there transitions worth naming? If both answers are no, useState is simpler and you should use it. Independent values that change on their own do not become clearer by being routed through a switch statement. The moment 2 pieces of state have to change together to stay correct, they were 1 piece of state all along, and a reducer is how you say so. Type the actions if you are using TypeScript, because a union of action types turns a typo into a compile error and gives you exhaustive checking on the switch. Keep the reducer pure, no fetching, no timers, no random numbers, no reading the clock. Those belong in the handler that dispatches or in an effect. And give actions names that describe what happened rather than what to set. Submit failed is a better action than set error because the first one lets the reducer decide everything that failing implies. And the second has already made that decision at the call site, which is precisely the scattering you move to a reducer to avoid. A reducer is a pure function from state and action to the next state. Dispatch report what happened, the reducer decides what it means. It suits state whose parts move together and collections with several operations. It is testable without React. And it is not an upgrade from useState. It is a different tool, and using it for two independent booleans makes code worse rather than better. 4 separate pieces of state in one component, and every handler updates 2 or 3 of them. Read the submit handler and count the things it has to remember, set submitting, clear the error, and on the way back either reset the fields or set the error and leave them alone. That knowledge is not written down anywhere, it is spread across the handlers that happen to implement it. Add a fifth field or a second way to submit, and the same sequence has to be repeated correctly somewhere else. Nothing here is wrong yet. This is what the code looks like just before it becomes wrong. The same component with one reducer. The state is one object now, and every transition is a case with a name. Read the reducer on its own, and it tells you what this form can do and what each event implies, without any markup in the way. The component underneath got shorter, and more importantly, its handlers stopped making decisions. They dispatch what happened and stop there. One thing to notice is that the reducer never touches the network. Submitting is still done by the handler, which dispatches before and after. Keeping the function pure is what lets you read it as a description of the rules rather than a sequence of events. The last variant is the collection case at full size. Add, toggle, remove, clear, completed, each as its own case, each returning a new array. Read them together and you have the complete list of things that can happen to this data, which is a genuinely useful thing to be able to hand someone. Look also at what is not in the reducer: no identifiers generated from the clock, no sorting that depends on anything outside its arguments. Everything it needs arrives in the action. That is what makes it a function you can test with a table of inputs and expected outputs, and it is the practical benefit that survives long after the readability argument stops being interesting. The model to keep is that dispatch describes an event and the reducer owns the consequences. Once those are separate, the rules of your state live in one pure function that you can read, test, and change without touching a single component. Use it when the parts of your state move together or when the transitions have names worth writing down. And when they do not, use state is still the right answer, which is worth saying because this is a hook people adopt everywhere the moment they understand it. The kata is the part that matters. Open the lesson, write the code yourself, then read back what you wrote and judge it. The link is in the description, and that practice is what keeps the skill yours.